All right, so this new unit is called Systems of Equations, and we're starting off with level 1. Our goal is that we can solve a system of two linear equations in two variables by graphing, and then I can also identify special types of linear systems that result in no solution or infinitely many solutions. So right now what I'd like you to do is complete the warm-up. Hit pause on this video until you have completed both of these for a warm-up. When you've finished, hit play. So we know that a coordinate is x comma y. The axes have been labeled for us. I know that over here we're at positive 1, 2, 3, 4. If I go in the opposite direction, it's negative. Going up on the y is positive, going down on the y is negative. Negative 1, negative 2, negative 3. So when I plot this point, it's positive 3 on the x-axis and then 0 on the y-axis. So if I go to positive 3, 1, 2, 3, and then 0 up and down, this is that first spot, A. If you made a mistake, fix that on your paper right now. The next one is negative 1 on the x, negative 3 on the y. Negative 1 on the x, and then down 3 on the y. And then finally, positive 4 on the x, so 1, 2, 3, 4, and then negative 2 on the y-axis. Like I said, positive 4 on the x, negative 2 on the y. So those are the 3 points. If you made a mistake, please fix that. We're going to do all graphing in this level 1, and so make sure you remember how to do this. Our slope is always whatever number is in front of the x, which in this case is a 1, and then the other number represents our y-intercept, or where we start. Y-intercept means where does it intercept or intersect the y-axis. So in this case it's at negative 3. So that's where I'm going to start, and then the slope is positive 1, which means I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. Make sure when we're graphing during this unit, it's extremely important that you carry your points as far as you can, and that you use a ruler. And you'll start to understand why that's so important as we get into this video further. Next, this other one, the y-intercept is at positive 1, and then the slope is negative 1/2. That means we're going to go down 1 over 2, down 1 over 2, down 1 over 2. If you've made a mistake, hit pause and fix your notes. Okay, next, what I want to show you about a system of equations is what exactly it is, which we'll get into on the next page. Actually, yeah, let's go to the next page and then we'll come back to our story problem, which is a lot easier than it looks. I know you see a lot of words there, but it doesn't mean it's hard. So here we have a system of linear equations is a set of two or more linear equations containing two or more variables. So here I have two equations, and in each equation there's two variables, an x and a y. So a system is basically whenever we have two equations. So this system has been graphed on this line. And so we can see this is our one equation, y equals negative x plus 5, and then this one's y equals 2x minus 1. The solution, so the answer to a system is, let's see, what is that answer? The solution to a system is a blank that belongs to, what do I have for that? The solution to a system is, I want to say it's a set of points that belongs to the lines. Oh, it's an ordered pair. It is an ordered pair that belongs, I'm just going to say a point, is a point, comma, x comma y that belongs to both. Oh, that's what it is. Could not remember what I wanted to write there. So sorry for that. The solution to a system is a point, written x comma y, that belongs to both lines. So is there a point on this system that belongs to both lines? The answer is yes. It's this one right here. So the solution to this system is 2, 3. And that would be my answer. So to recap, a system of equations is any time you're using two or more equations, and then when you graph them, the answer to the solution is the one point that they have in common. So in this case, the solution was 2, 3. So now let's go back to our story problem to kind of see how this would actually work in real life. Mason is going to the water slides and needs to figure out which deal is better. He can pay $30 to go on water slides as many times as he wants. Or he can pay $15 to get in plus an additional $1 per trip down the water slides. If Mason goes on a certain number of trips down the water slides, the two options are equivalent in terms of cost. How many trips would that take? So how many trips would it take before they're at the same exact price? So write a system of equations, graph them, and then figure out what the solution is. So in the one situation, it's kind of like he's just getting a wristband or something. He's paying $30 and he can go down it 1,000,000 times if he wants. So one equation is going to be y equals 30. And graphing that is going to look like this, which makes sense because if he goes 0 times down the water slide, it cost him $30. If he goes down 10 times, it still cost him $30. If he goes down 37 times, it's still going to cost him $30. So no matter what, this is what that line's going to look like. The other one, though, he has to pay $15 no matter what, but then every time he goes down, it's an additional $1. So our starting amount is $15, and our growth, it's going to grow by $1 every time he goes down the slide. So y equals 1x plus 15. Our growth was 1, our starting point was 15. So our starting point is 15. These are counting by 5s. And if we go up 1 over 1, that can be a little bit confusing how you're going to graph this because it's counting by 5s. So instead, let's think of it as if I went up 5 over 5. Up 5 over 5, up 5 over 5, because that's the same thing as just going up 1 over 1 5 times. So I can go and use these boxes because they're counting by the same amount on the y-axis and on the x-axis. And if I continue and draw this line, then I can see the one point that they have in common is this point right here, which is 15, 30. 15 is the x-axis, which means it's the number of trips, and the y-axis represents the cost. So this tells us that after 15 trips, the cost would be identical. So the solution would be 15, 30, but since it's a story problem, I'm going to say after 15 trips down the slide, the cost would be the same. Take a second to process that. Hit pause and let it sink in. But this is what a system is. It's anytime we're comparing two things and we want to find out at what point are they going to be the same, we can use this information because then this tells us, well, Mason might have an idea how many times he wants to go down the water slide. Maybe he was hoping to go down 50 times because there's nobody at the park, so he's going to ride. But maybe he knows he really only wants to go down once or twice and he wants to spend his time maybe in the lazy river or something else like that. So this is helping him get a better understanding of where the value is more important to him. So he can pick a cost that's going to be more beneficial to him. So this is systems. We can apply these to a million different things in life. This is just one of an infinite amount of examples that we could use. So the solution is the point where they cross, which tells us until we get to that point, it would be cheaper for the second option to pay the 15 at first. But if we're going to go more than 15, it's definitely a better value at 30. So, to recap, again, a system is a set of two or more equations, and that when we graph them, the point that they have in common is the solution to the system. However, there are three different types of solutions to a system. One is in the event that you have only one solution, which is what we just talked about. So in that case, that one solution would be right here, right where they cross. However, sometimes you might get no solutions, and that only happens if we have parallel lines. Because we know parallel lines will never touch, so they're never going to have a point in common, and so therefore there is no solution. Or our third option is infinitely many solutions, and that is the idea that you graphed one line and then you ended up graphing the exact same line. The lines are identical. And that means every single point is a point that they have in common. So if they have all of their points in common, they're going to have an infinite number of solutions. Oh, I guess I don't have to rewrite that because it's written right there. So let's come back up to our number 2. For our goals, I can identify special types of linear systems that result in no solution or infinitely many solutions. Can you look at a graph and recognize if they're parallel, which means there's no solution, they intersect, which means there's one solution, or can you recognize that you just graphed identical lines and that they're going to have every single point in common? So if this isn't making sense, hit pause, let it sink in, reread what we've just written, or rewatch. Let's flip to the next page. So what I want you to do is take a second and ask yourself, what are the solutions to these three examples based on do they have one solution, no solutions, or infinitely many? So go ahead and hit pause and write your answers here. So as we can see, the solution here, there is one solution, and technically it's -2, 0 if you want to get fancy. Here, I can see that the same line was graphed twice, so there are infinitely many. And there are no solutions because these ones are parallel. Okay, for the last bit of what we're going to do, we're not doing anything new. We're just putting ideas together. When you solve a system by graphing, we're going to graph each of these lines, and the point where they intersect is our solution. So, if you know what you're doing, go ahead and work ahead of me. This first one has a y-intercept of +3, and then the slope is 1. Up 1 over 1, up 1 over 1. I'm telling you right now that the more points that you graph and the more perfect you draw your line, the happier you're going to be because you're going to make less mistakes. If my solution is way over here and I drew a wonky line that's the slightest bit not perfect, I'm going to get the wrong answer. So I strongly recommend continuing your points to make it easier for you to identify your answer. So my y-intercept here is at +5, and then my slope is +2. So that means I'm going to go up 2 over 1. Now, I can continue that linear pattern in the opposite direction by going down 2 and over 1 in the opposite direction. And then I can see exactly where these share a point. So I can see that the solution to this system is -2, +1. If I'm going too fast, hit pause and catch up, but make sure you're processing what I'm talking about. At this point, you should be able to go ahead and try this next one on your own. The example down below is maybe a little bit tricky. I'll obviously walk you through that, but challenge yourself. Hit pause and beat me to all of these. The y-intercept here is at -3, and then my slope is +1. So I'm going to go up 1 over 1, up 1 over 1. Again, use a ruler. For the next line, my y-intercept is -1, and my slope is -1, which means I'm going to go down 1 over 1, down 1 over 1, and I can immediately see where my point of intersection was. The one point that these two lines have in common, +2, -1. Hit pause if you need to. Oh, did anybody catch my mistake? That's wrong. Sometimes I'm a little dyslexic. This is +1, -2. If you caught that, give yourself a pat on the back. All right, the next one. How in the world are we going to graph that first equation? Well, I personally prefer to rearrange it so that way it's in slope-intercept form, which means I need this x to move to the other side. To move it, I have to do the opposite of addition and subtract it. I do not need to keep the 0, but I am keeping it because it helps me recognize that my y-intercept is therefore 0. Hit pause. If I went too fast here, slow it down, rewatch it, take the time to process what just happened. So from there, my slope is -1. So that's our very first line. And this is also why it's really important to extend your lines from one edge to the other edge, because if your solution is down here, if it's in this corner, I'm going to be a little annoyed that I stopped shy. Y-intercept is +1. My slope is down 1 over 2, down 1 over 2. And if I continue this pattern, this linear pattern in the opposite direction, I can see that my y-intercept is right there. And my solution is -2, +2. So this warm-up that we did to start the day was all about, can you plot your points, can you recognize what the points are, and can you graph lines? Because those are the only two skills we're actually using. It's all review. So hopefully you really like level 1 because of the fact that it's a review. So y equals 2x. That means my y-intercept is 0. And then up 2 over 1, up 2 over 1. Hit pause and beat me to this. Next, my y-intercept is -5. And then my slope is up 2 over 1, up 2 over 1. Well, what the heck happened there? They have the same slope, which means these lines are never going to intersect. They will never share a point or have a point in common. So the solution is that there is no solution. That's it. Level 1 is only a review. So what you need to be doing at this point is, on the next page, you are completing the top, which is answering these. Do they have one, none, or infinitely many solutions? Then 4 and 5 are a review of what we just did on page 4. And then finally, you're going to grab a Chromebook and you're going to complete this section on IXL. I am going to sign off on this. It was not my intention to be absent today. So I will be signing off on this. Make sure you get it done. It is a grade.